Alright, silly people, here's the situation. We're just proving uh, vector, uh, a vector algebra identity, um, that the sum of all of these triple vector products will give you zero. Um, so the way I'm going to do this is um, there's a funny vector product rule that's called the VACCAB rule, also the vector triple product, where it's A cross B cross C is equal to the vector B times A dot C minus the vector C times A dot B. So we're just going to apply this product rule to each of these triple vector products individually, and see that all of the things get canceled out. Um, so the first one is just a verbatim copy it down sort of thing. Uh, da, 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 da. And so, okay, the next term, you're gonna have it's C times B dot A minus A B dot C, and then you're gonna end up with A times C dot B and B times C dot A. All right. Now that we've applied that rule throughout the expression, we can collect terms. So we're going to end up with B times A dot C minus C dot A plus A C dot B minus B dot C, and then C with B dot A minus A dot B. Now, these are all real vectors, so their dot products should commute, um, which means cancel out, cancel out, cancel out, cancel out. You end up with zero. That's not too bad. Next part of the problem asks us, under what conditions does A cross B cross C is equal to A cross B cross C? Now, um, seeing that this is in the same problem that uses the triple product identity, I think we should probably use that as well. Um, Making use of the fact that with cross products, if you want to um, change the order of it, you just have to flip the signs. So A cross B cross C, that is going to be the same thing as minus C cross A cross B, right? Um, so under what conditions is that true? Well, the stuff up top is always true. And so just plugging that stuff in, plugging in this expression to replace this expression in the identity. Um, you'll have minus C cross A cross B plus B cross C cross A plus C cross A cross B, and look at that. You get a little bit of cancellation. So this should go away. This should go away. The whole thing is equal to zero, which means for this relation to be true, then B cross C cross A has to be equal to 0. Geometrically, what that means is that um, if a cross product, if the result of a cross product is 0, then that means that the two vectors you're taking the cross product of are parallel, which means B better be parallel to both, or to the cross product of C and A. Um, right. In turn, C cross A has to be parallel to, or has to be perpendicular to both C and A individually. Which means also that B has to be perpendicular to C and B is perpendicular to A.